Okay, let's take a look at the equations that you're going to need for this. Let's look at the horizontal position as a function of time for projectile motion. So your horizontal position is going to be equal to the initial velocity in the horizontal direction multiplied by time plus the initial position of the ball, where it started in relationship to the starting point. A lot of times this cancels out, this last part cancels out in zero, because we usually assume it starts at the start most of the time. Not all the time, but most of the time we'll see this one cancel out. So a lot of the time we're just going to be using a simplified version of this right here. And it just simply comes from your original equation for velocity, right? Velocity, which was change in position over time. Well, we can look at it, we can rearrange it to position as velocity multiplied by time. We're just specifying a very specific velocity. The initial velocity in the horizontal direction, that's what x is. So we're going to start using some x's here to specify horizontal, and we're going to use some y's to specify vertical. So let's look at the vertical position. Many times we'll change this x to a y, okay, and we'll use 1/2, in fact, 1/2 at squared. And many times it's going to be a negative now, because the acceleration is in the downward direction. So we've got to have that negative in front. The initial velocity in the vertical direction multiplied by time plus where it originally started from. And this just comes from the equation where we're using 1/2 at squared plus v naught t. Oops, this is going off the side there. Sorry about that. Let me rewrite it here. at squared plus v naught t plus x naught. There we go. And we've been using that equation for a while. But now look here. You can see that we're replacing x with y. Why? How come we're doing that? What does that mean? Y-axis. Yeah. We're now referring to that as vertical. The vertical position here. Okay, so now we've got the vertical velocity. Let's get the equation for the vertical velocity. The vertical velocity is equal to negative gt plus the initial velocity in the y direction. Sorry about that. The initial velocity in the y direction. And that just simply came from the equation here, okay, that original equation, that kinematic equation. But now we're saying the vertical velocity, so we put v subscript y, meaning vertical velocity, is equal to negative acceleration due to gravity multiplied by time plus the initial vertical velocity. That's what the little subscript y means. All right, and finally, let's write an equation for the horizontal range of a projectile over level ground. Let's do horizontal range. Go back through, identify all the symbols that are used above. All right, so if you look at those things, we've got the horizontal position, the vertical position, the horizontal initial velocity, the acceleration of gravity, the initial horizontal position, initial vertical velocity, vertical initial velocity, and time. So those are all the ones up above. Now, let's start solving an example problem on this. Example problem number 1. A student throws a ball horizontally off a roof of Berkner High School, 20 meters above the ground. The ball strikes the ground 60 meters away from the base of the building. How fast did the student throw the ball? We want to use g equals 10 meters per second squared. So let's use our guess method here. Let's list our givens and our unknowns. If you look up there, we can see that the initial vertical position of the ball is 20 meters. Okay, the final position of the ball is 60 meters. We would assume the initial position of the ball should be 0 meters. Okay, and then the final vertical position of the ball, if it fell, if it's initially 20 meters away from the ground, it's going to eventually come to also 0 meters. It hits the ground. All right, so then what are some things that we are going to need to know? We have to assume g is equal to 10 meters per second squared. And we need to assume that the initial vertical velocity of the ball is 0 meters per second, that it's not moving in that vertical direction initially. All right, so we're going to look at how fast did it go. We need to know how fast. We need to know some kind of velocity. Well, which velocity are we really looking for? The initial velocity in the x direction. So we're going to have to use more than one equation to solve this. We can come back to this equation here. Okay, so if we look at this equation, we know this is 0 right here. That goes away. And we're usually simplify a lot of these equations, going back to like the free fall ones. Now on this one, we're really going to be solving for the initial velocity in the x direction, which is equal to, yep, it's change in position over time. Well, we know it's change in position. What's its change in position? Right, 60 meters. It went 60 meters horizontally. That's given to us in the problem up there. So then the big problem is finding out time, how long the ball is in the air for. So we need a second equation for that. Well, we're going to use this one. And then we want to solve it for time. Well, we know that the vertical velocity, the initial vertical velocity was 0. So this goes away. And we know that it started a certain distance away from it. Okay. So that's going to go away. That's going to go 0. This one also goes to 0 here. So we can start simplifying this formula. What we can start saying then, let's move the 1/2 to the other side. So we can say 1/2, sorry, wrote that wrong. Wrote my equal sign too soon. Try that again. We can say 1/2 gt squared is equal to the initial vertical position. And then we can solve this for t. So move 2 back over to the other side. So we can have t squared is equal to 2 times this over the acceleration. And you've seen that before. And that just comes from t equals 2 over a. Yep. But now, instead of using the x, we're using the y, indicating that's a vertical position here. So now let's plug in some numbers. So we know the time that's in the air is 2 seconds. So the initial velocity in the horizontal direction then had to be (30 meters per second).